Oscillators are a core electronics component that control the timing for devices ranging from your watch to your laptop and mobile phone processors to even controlling the display of the device that you're watching this video on. In a nutshell, oscillators can generate AC voltage signals from a simple DC voltage source. That means they can create AC voltage graphs that look like this from a very simple and boring DC voltage graph. In this video, we learn about how oscillators work, the different terminology associated with oscillators, and also the different types and use cases for oscillators. Now, before we dive into oscillators, we must learn about this one term called frequency. A wave frequency refers to how often a wave completes one full wavelength or one wave cycle within a set time frame. A higher frequency wave signal looks something like this, with more wave cycles fit inside this voltage versus time graph with a very short peak to peak distance. Meanwhile, a lower wave frequency looks more stretched out, something like this, and can fit less wave cycles in the same duration of time in this voltage versus time graph. This frequency is often measured using something called hertz, which refers to the number of wave cycles within 1 second. Now, going back to oscillators, there are two different types of oscillators: sinusoidal and non-sinusoidal oscillators. Sinusoidal or harmonic oscillators provide more natural looking sine-like waves. Such oscillators typically range from 20 Hz all the way up to 1 GHz. Diving a bit deeper, we actually have two different types of sinusoidal waves. There's a damped and undamped waves. Now, undamped waves look something like this, where the amplitude or the height of your wave signal stays the same, whereas damped wave signals look something like this, where the amplitude or the height of the wave becomes shorter as time goes on due to some power loss. Now let's go back to the two different types of oscillators. Remember there was a sinusoidal oscillator? Well, there are also non-sinusoidal oscillators, also known as relaxation oscillators. These non-sinusoidal oscillators create waves that look like triangular waveforms, square or rectangular waveforms, or even sawtooth waveforms. Such oscillators typically have frequencies ranging from 0 Hz all the way up to 20 MHz. Next, let's talk about how oscillators are used in different circuits. We'll start with the LC or RF oscillator configuration that gets its name from the capacitor and inductor used. These oscillators are known for very high frequency waves. These oscillators are often used in radio receivers, where you can tune these oscillators to selectively amplify the frequency that you want to listen to without much noise from other frequencies. This tuning can be done by adjusting either the inductor or the capacitor within this oscillator circuit. Next, we have the RC oscillators that are created using resistors and capacitors, and these oscillators, unlike LC oscillators, create low frequency waves. These oscillators are often called audio frequency oscillators due to their ability to generate audio frequency signals. Next, we have the negative resistance oscillators that use the negative resistance characteristics of its electronics devices, such as tunnel devices. We also have the UJT relaxation oscillators that use both capacitors and resistors to create those sawtooth waveforms that we were talking about earlier. Next, we have the common crystal oscillators that use quartz crystals to generate very stable frequencies up to 10 MHz. A cool alternative to the crystal oscillator is a MEMS oscillator, which is basically a microscopic tuning fork that's used to create these oscillating frequencies. As a cool fact, some iPhone models actually use this MEMS oscillator, and if you have seen the recent news articles, this is the very reason why recent iPhone models have failed in a very helium-rich environment, because these MEMS oscillators used inside these iPhones are sensitive to these helium-rich environments. Lastly, I want to leave you with the 555 timer circuit IC. This incredibly powerful circuit is often used as a variable oscillator by hobbyists like you and me in their projects. Anyway, that's it for this video tutorial. Thanks for watching.